What is a series? Well, a series is a little bit different. A series will have possibly this next symbol, if you've never seen it before, which kind of looks like an E. It's the Greek letter sigma. And what that's used to denote is addition. It means you're going to add up or sum up something. Well, so sigma, this big E-looking thing, will have something usually below it, above it, and out in front. The number that's at the bottom, or the thing that's at the bottom, is going to tell you what to start when you start adding. So the bottom part here is always where you're going to start adding, what number. So if it's n equals 1, n equals 2, it's what number you're going to start with. And you work your way up and continue adding until you get to the last number at the top. That's where you're going to end. So this tells me to add up all the numbers, starting with n equals 1 and ending with n equals 4. What are we going to do with our n's? We're going to just plug them into this formula here where it just says plug in an n. So if we were just using this example, what this example would be is it would tell you to plug in n equals 1 first. And the little sum, the sigma here, means add up. Then go to your next number. Well, number 2. And we plug it in. And when you're just plugging it in for n, it's just going to leave it as a 2. Keep on doing this and adding as you go along until you hit the last number at the top, which is the 4. So the next number we'd hit is adding a 3. And then the last one we do is adding a 4. When we hit the top number 4, we're done. We stop, and that's what we need to just go ahead and add up everything that we have. Well, the 1 and 2 is 3, plus 3 more is 6, plus 4 more is 10. So our answer here for this example for a sum would just be the number 10. Sometimes you'll hear a fancier name for this sigma, and you'll hear the term sigma notation. And we use it to write sums as follows. Here's another example. What it says here is that we've got a sigma, means we're going to add up starting with we're going to use i's this time, 1, and we're going to work our way all the way up to n. They don't tell us what n is, so that means n could be anything. So that means you would start with 1, so you do plugging in 1 would give you a sub 1. And then you'd keep on going a sub 2, a sub 3, until you hit whatever number n is. So we're just going to leave it as a generic n. We don't know what that is. So again, just like before, as we were explaining, the bottom number is where you start adding things up. This is where you plug it in, is the thing that's on the side. You add along as you go, and then you stop adding when you hit the number on the top. So what we'd like to do is look at a few examples written out with this fancy notation and figure out what a specific series, again, series means that we're adding a bunch of stuff, actually what it adds up to. So let's look at problem A. In problem A, we have a sum, sigma, that starts at 1 and ends at 6. What are we summing up? Each time we're going to look at finding out what 3i minus 2 is. So we're going to start at the beginning, which means we're going to start with 1. So the first thing that we're going to do is plug in 1 here for I. Well, if we plug in 1 for I here, we'll get 3 times 1, which is 3, minus 2, which is 1. Okay, so if we plug in 1 for I, we get out 1. So that's our first value. Don't forget, we're going to add it to whatever other values we get. That's why we see an addition sign here. Now we need to plug in 2. We're going to keep on plugging in until we get to the top number 6. So if we plug in 2 now, well, let's see. We get 3 times 2, which is 6, minus 2 is 4. So when we plug in 2, we get 4. Adding. We have to plug in the next number. Well, the next number we're supposed to plug in is 3 because we're not at 6 yet. Keep on working your way up. Plugging in 3, we get 3 times 3, which is 9. Minus 2 is 7. So when we plug in 3, we get 7. Again, we're still adding each new term that we get. Next term is plugging in 4. So we get 3 times 4, which is 12. Minus 2 is 10. Okay, again, we're adding all the way. Okay. Now let's plug in 5. 3 times 5 is 15. 15 minus 2 is 13. Okay. And again, keep adding. We've got to look at our last term here. We're going to add our last term. How do I know this is our last term? Because this is when I equals 6. We're plugging in 6 now, so that is when we're going to stop. This is going to be our last one. So plugging in 6 for I, we get 3 times 6 is 18. Minus 2 is 16, so our last term is 16. So we got our 1, our 4, our 7, our 10, and our 13, and our 16, and we should be adding those up as we go along. And when we add them all up, we get the number 51, and that is the value of our series when we actually have them all added up. So that's our final answer. In problem B,